Hi everybody, this is Professor Pettit for Math 161. I'm going over just creating a video of a really quick for your Math 161 Exam 1. I wanted to kind of walk you through some potential questions. Understand that what I did was I went through the entire test, took notes and made up alternative problems that were very similar to the ones on the test so that you guys would have something to go from. Okay, so just to kind of give you an idea of what everything's going to be, what it's going to be on, and everything it's going to cover. So basically, we went over a function, what functions are, and I'm going to go ahead and write up notes here for you guys. It's just too green. So a function is a special type of relation in which one element of the domain is paired exactly with one element of the range. Basic reason for that is that if you're when you're looking back at domain and range for when you had ordered pairs, so let's say I had a set of ordered pairs where it's -3, -9, -2, -1. This is just a relation here. Okay, so if we look here, remember that our domain is all the input values, or in this instance, it's always going to be your x values, okay? So these values are your x values, and the blue values are your y values. All right, now here's the key thing. When you have a set of points listed, the key way to make sure that something is a relation or not, or a function or not, is to ensure that the x values do not repeat. Unfortunately, they do here, so this relation is a relation, but it is not a function. Okay, so when you're looking at ordered pairs, if the x values repeat, then it is not a function. If they don't repeat, then it is a function. And my domain would be listed like this. Is -3, -2, -1. And my range, notice how I don't um, list the repeating x or y values when I do that. I have -9, -1, and -6. Okay. Also, as you go and look at graphs, remember there is a thing called the vertical line test. And a vertical line test says that if you can draw a vertical line, vertical meaning up and down, through any point on a graph and hit that graph more than once, then it is not a function. Okay, so what does that mean? All right, so let's look at some of our basic graphs. If you're looking at a parabola, which usually points up or down, that's almost always a function. Lines, as long as they are not vertical lines, are functions. However, if you go into conics and you're learning about parabolas on their side, those are not considered functions because I can hit that graph twice, right? In addition, vertical lines are not functions as well because the x value repeats for every element of the range. Okay, so these are the main ways that we look at it. We also do mapping as well and tables for domain and range. If you have any other questions or if you have any specific homework questions or stuff that, or quiz questions that you want to go over, please contact me. You can even send me a screenshot of the question and I can go over it, make a video for you. Okay? Because I know sometimes it's hard to um, schedule office hours and stuff like that. Okay, so that's basically it for functions. Well, as far as determining whether something is a relation is a function or a graph is a function. Um, the next thing they're going to talk about is whether a function is even or odd. Okay, so a function is even if it is symmetric with respect to the y-axis. So very often I look at the graph of the function just to ensure that, is that, I think that's odd or I think that's even again. So if it's symmetric with respect to the y-axis, so an example of that would be like the x squared function, right? Now, if it's moved to the left or to the right, it's not necessarily even anymore, right? But if you just have y equals x squared or y equals negative x squared, it is even. All right? A function is odd if it is symmetric with respect to the origin. That's kind of a weird way to look at it, but one way I could tell you is like something that's odd is if you have the equation y equals x, that's a line that has a slope of 1 that goes directly through the origin, right? It's symmetric with the origin, okay? So definitely, it's a really abstract concept, and frankly, I'm going to be honest, I don't love it, but it is something that is covered a little bit, and I want to make sure you guys understand. Okay, so the next thing that they really wanted to talk about were relative maximum and minimum of functions, and I kind of wanted to show you like an example. So if I did something like this, right? Okay, it's a horrible drawing, so please just bear with me. But let's talk about critical points. So critical points are points where a graph changes its direction. You can have absolute maximum or an absolute min, or you could have a relative max, or a relative min, or both. Okay, so if I was talking about an absolute max, I'd be talking about the vertex, the highest point of the entire graph. Okay, now sometimes it's very hard to tell if that's the case, um, but if you're talking about like a parabola, the vertex is either an absolute max or an absolute min, right? It's an absolute max when it's pointing downward, and it's an absolute min when it's pointing upwards. Now, relative max and relative min are still in because you might have an equation that has a ton of turning points, right? So here, both here and here are relative max because in that area, in that relative area, it is a maximum point. And again, this is a relative minimum. It's not the lowest point of the graph, but in that area, there is a point of inflection. There's a point of, not inflection, I'm sorry, a change of direction. Okay. A point of inflection is where a graph changes shape but not direction. So let me show you an example of a point of inflection. So I'm going to define that. A point of inflection is where a graph changes shape but not direction. Now, a perfect example of that is when you have y equals x cubed. If you are, when you go right to the origin of the graph, there's a point right here at 0, 0 where it still kind of changes shape. This is a perfect example of a point of inflection. Okay. All right. Okay, a couple of other things that you guys need to do is determine the slope of a line and also write the equation of a line. So let me just give you an example. So if you write the equation of slope, the equation, I'm going to go ahead and write the equation of the line too and determine the slope. Okay, so if I have 2 points, negative 9, 3, and negative 5, 7, okay, I'm given an x value and a y value of the first point and an x value and a y value of the second point. Now the slope is the ratio of the vertical change, which is the difference in the y values, over the horizontal change, which is the difference in the x values. Okay, so if I were to calculate this, and I just made up these points, so please bear with me if they're horrible. If I have 7 minus 3 divided by negative 5 minus negative 9. Now be careful with your positives and negatives. 7 minus 3 is 4, and this becomes -5 plus 9. So that is 4, so my slope is 1. All right? Okay. Now, if I'm going to write the equation of the line, I'm going to use something called point slope. Because I'm given a point on the line, and I'm given the slope, I'm just not given anything else. So I do y minus y1 equals m times x minus x1. Now, and then I'm going to change it to slope intercept, which is your y equals mx plus b, which is what you guys always like. This is, remember, your y-intercept where the graph crosses the y-axis. So what I'm going to do is substitute a value in, oh no, sorry, a value in for here, here, and here, right? So I'm going to use the same x1 and y1 that I have here that I've already been given. So I'm going to do y minus 3 equals my slope, which is 1, times x minus x1. So that's x minus -9. So then that first step is substitute. And then I always say you simplify. You probably skip this because you do it anyways. Y minus 3 is equal to 1 times x plus 9. Then I distribute. Now, obviously, if this wasn't 1, it'd be a different number, but that's okay. So I have y minus 3. I'm distributing this number into here. Well, 1 times anything is just that number. So that's x plus 9. And then my last step is to add or subtract. So I'm going to add 3 to both sides. So my final equation is y is equal to x plus 12. I'll go over another example as well. Maybe one where I'm given the y-intercept, and we'll go from there. Okay, so you also talked about combinations of functions, right? Where, let's say if I have, and they want us to deconstruct a combination of functions. And you're like, what the heck is that? And I'm like, let me show you. So let's say I had a function where I'm going to say h of x is equal to 1 minus 2x. And that is equal to f of g of x, right? So, and I'm sorry, quantity cubed. So what is f of x and what is g of x? Well, I'm going to go to get g of x, which is the most internal thing. I'm going to use the inside, right? So that's 1 minus 2x. And then f of x takes anything into account that's on the outside. So that's going to be x cubed, okay? Now this isn't exact, but it's very similar to the question that's on your test. So definitely it doesn't get any more complicated than this. So hopefully you should be in pretty good shape with that. The other thing I wanted to talk to you guys about was limited domain, right? We have limited domain in two major occasions, right? When we have a rational function where x is at the bottom, where x is at the denominator, is in the denominator. And the reason why is the denominator cannot equal 0. And then we also have a square root function And anything under the square root cannot be negative. Because if we take the square root of a negative number, it is an imaginary number, and that we don't do domain and range through imaginary numbers. So let me give you some examples of those. Um, and I know it seems like I'm popping around, but I'm literally just going through the questions on the test. Okay, so let's go ahead and let's say I have 1 over x minus 2. What is the domain of this function? All right, and let's do the square root of 7 minus x. What's the domain of this function? So in order to do that, I take the denominator of the function and I set it equal to 0. Okay, so I'm going to add 2 to both sides and I get x equals 2. So that tells me this is the value that x cannot be in the domain. So I would write this down as all real numbers except x cannot equal 2. All right. And they wanted it in interval notation. So if they want it in interval notation, I would write this as it goes from negative infinity to 2, right? But it doesn't include the 2, so I have the parentheses. Remember, if you include that value, that's like a closed circle, right? And this is like an open circle, right? And then it goes from 2 to positive infinity. And I would do a union in between the two. All right. Now this one, I say, okay, 7 minus x has to be greater than or equal to 0. Okay, so it can include whatever that value is. It just can't be negative. So I'm going to subtract 7. And I have negative x is greater than or equal to negative 7. And then I divide by negative 1. When you divide by a negative, remember you flip the sign. So x is now less than or equal to 7, right? Because 7, it has to be less than that, right? So how do I write that? So when it's less than or equal to, when you do domain, you go from the lowest value to the highest. So it's going to, the lowest value goes to negative infinity, right? And then 7 is the largest number it can be. So I put a bracket around that. Okay. All right, so let's do another problem. I'm going to try to move through this as quickly as possible, but not rush you. This is probably going to be a longer video, so feel free to come back to it later if you need to. So the other one is the average rate of change, and that is the slope of the secant line of a graph, right? And the formula for that is the function of b minus f of a divided by b minus a. And what the heck does that look like, right? So let's say I have a function of negative x squared plus 6x. Sorry, I'm going to undo this real quick. Undo. Sorry. F of x is equal to negative x squared plus, oh, for heaven's sake, sorry guys, negative x squared plus 6x minus 14. And they want the average rate of change in the interval of negative 1 and 2. All right, so this is my A and this is my B. Okay, so I can already write that down as 2 minus negative 1, right? And then I'm going to do f of b, which is f of 2, which is negative 2 squared plus 6 times 2 minus 14. So that's going to be negative 4. Remember that negative's on the outside. I'm not squaring negative 2. I'm squaring 2 and then multiplying it by negative 1. So be careful with that. So then that's plus 12 minus 14. So that's going to be what? Negative 18 plus 12, which is negative 6. All right. So that's going to be right here. And then f of a is equal to negative 1 times negative 1 squared plus 6 times negative 1 minus 14. So that's negative 1 minus 6 minus 14. So that's equal to negative 21. So it's minus negative 21. So I get plus 21. What is that? Negative 15, or 15, I'm sorry, 15 divided by 3, which is 5. Okay, and that's your average rate of change. It's just like kind of like taking the slope, but it's through function. You have to evaluate the functions. Okay. If I have time, I'll go through another equation of a line, but I don't want to do too many. The other thing you need to do is explain how graphs are transformed. And I really wanted you guys to see this and explain and also graph things that were transformed. So remember that if you have a function f of x, right, it can be transformed in several ways, right? We can have a times f of x plus or minus h, right? And then plus or minus k, right? So let's look at this. So if we have a times f of x, and all you have to do is just break this apart. Okay, so if the absolute value of a is greater than 1, then that is a vertical stretch. And then if the absolute value of a is between 1 and 0, right? It can't be negative. If it's negative, remember that's a reflection over the x-axis, and I'll talk about that in a minute. But that is a vertical compression. Okay, so if I did f of x plus h, it's exactly the opposite of what you think of. It's going h to the left. And if I did f of x minus h, that's h to the right. Then if I do f of x, if the numbers on the outside of the parentheses are grouping symbols, so if you're talking about a absolute value function, I'll give you an idea of what I'm talking about. I'll give you two examples what happens, okay? So let's do that. Oh, so f of x plus k means it's going up k units. And then f of x minus k means it's going down k units. So let's say we have a function like this. I'm going to give you two examples. So I have a function of 2 times x, the absolute value of x plus 3 minus 4. Let's take this bit by bit. This is a vertical stretch by a factor of 2. it's moved to the left 3 units and then down 4. Let me give you another example too, just so that you can see it. If I was given f of x is equal to 3 divided by x minus 5, this one's a little bit weirder because it's remember this is the rational function 1 over x looks something like this. Boom, boom, right? You have a horizontal and vertical asymptote, and it's like a hyperbola. Anyways, so this is going vertical stretch by a factor of 3. And that's this guy right here. It's going down 1 and to the right 5. It doesn't allow the use of formulas, but you are allowed to use a graphing calculator. So feel free to do that. Okay. Now, the next thing I wanted to show you was intervals where functions are increasing, decreasing, or constant. Okay, so let me just give you like an abstract graph for that. Now, when you're doing these intervals, they're going to be on a graph, right? And let's pretend that's a straight line. And you'll be able to see where these x values are. So let's say this is -5, where x equals -5. This is where x equals -2. And this is where x equals 0. And then let's say x equals 3. Okay, so it is increasing from the point where x is equal to -5 to the point where x is equal to -2. And then I'm actually going to do one right here. I'm sorry. And I'm going to say this is x equals 5. Sorry. And it's also increasing from 0 to 3. So as you can see, it's going up here and here. All right. And then it is going down here, right? So it's decreasing on the interval where x is equal to 3 and 5. The biggest mistake people make with this is they give me the y values in the interval, and that's not what I want. I only want the x values, okay? So it's like these are the boundaries. You're going to go, so this is like a GPS. You're going to go straight for this many minutes, right? That's all that I'm worried about. So this is constant. There's no change. Where x is between x is equal to 2 and x is equal to 0. So hopefully that kind of explains that to you. All right. Okay. Already did that one again. Okay. I also wanted to do a couple of other things too. Let me show you. Okay, so the first thing is let's do a piecewise function and write the graph and the domain and range. These are a pain in the butt. Nothing, I'm not going to even sugarcoat it. Okay, so here's the thing. Okay, so if x is less than or equal to 4, this is what the graph is, right? So this is the absolute value of negative 3 halves of the absolute value of x plus 5. So let me kind of give you an example of what I would do. So when you can draw this all by hand and do a table of values, but what I would do is take each one of these in parts. Hopefully this guy's going to pop up. Okay. So I'm going to use my calculator and do, let's see here. I'm going to do negative 3 divided by 2. Now to do absolute value, I go to num and I put x, right? And then I do plus 5. Okay? So we want where x is less than or equal to 4. So I'm going to graph it, so I'm going to get an idea of what it looks like. Okay? So that's an absolute value function that's shifted up 5 units, and this is a little bit steeper than the normal one, right? And it's also reflected over the x-axis. So we want x is less than or equal to 4. So let's bring up my table. Oops, sorry, second table. All right, so if I look at 4, I'm going to have the point -1. So I'm going to go from, so when it's less than or equal to 4, I'm going to go ahead and drag this over for a minute. So I'm going to go down. Oh, actually, I'm going to go up a little bit. Sorry, guys. Hold on. So these are some key points here, and we can use this to kind of come up with some points on the graph. So we have 4, -1. So 1, 2, 3, 4, -1. So that's my first point. And it's a closed circle because of this little guy right here. All right. And then I have 2, 2. And I have 0, 5. 1, 2, 3, 4, 5. Right? And then this is completely symmetric, right? So at -2, it's 2. And then it goes from here to negative, we go to -1 at -4. And then we keep going, right? And we stop it there, but it keeps going this way, right? Now, it's -2x plus 3 if x is greater than 4. So let me just go ahead and put that in my graph. So go to y equals, that's a line that has a y-intercept of 3 and a slope of -2, but we're only interested at it for where it's greater than 4. Okay, so I'm going to do -2x plus 3, and I graph it. See what I mean? It's a negative. So then I go to table, and I'm going to go from 4 on. So it's an open circle if where x is greater than 4, but I'm going to still graph that point. And let me show you what I do with it. So here's the table that I'm going to use just to get the basics. So at 4, it would normally be -5. So this is -1, 2, 3, 4, 5. So I have an open circle right here, right? And then it follows at 5, it's -7. So it goes down to over 1. So it's going to go like this. So in essence, this graph is defined through all real numbers, right? Um, because it's still defined through here. Even though here it's not defined, it's still defined here, and then it keeps going. So my domain is going to be all real numbers. Now my range, it's defined everywhere from this point down. So my range is going to be y is less than or equal to 5. If I wanted to do that in interval notation, I'd be doing negative infinity to positive infinity, and this would go negative infinity to 5, like that. Okay, so you will have to do one of those. I'm also going to give you so here is a piecewise function where you have to evaluate it given certain values. Okay, so if a is 8, all right, so that is the value that's greater than 1. I'm going to plug it into this equation. So, I mean, a of x, if x is greater than 1, so it's going to be negative 4 times 8 plus 7. So that's negative 32 plus 7, which is negative 25. All right. Now, if it's negative 7, it's right here, right? Because it's less than negative 6. So I'm going to do the absolute value of negative 7 minus 8, which gives me negative 15, but I take the absolute value of that, and it's 15. I'm not going to do every single one of these, but this one is where it's 1, right? So that would be in this interval, right? So we'd be using 2 times 1 minus 1 squared. So that'd be 2 minus 1, which would just be 1. Okay? So that's what the point is for using a piecewise function. That actually happens, believe it or not, when you do taxes and stuff. You use that kind of stuff with taxes and everything. So I know, lots of fun. A couple other things that I wanted to talk to you about. I'm going to do a couple of things. I'm going to do some combinations of functions. And I'll do a line that passes through a point. So first of all, we have the difference quotient. This is just the beginning of the derivative, right? So this is x plus h minus f of x divided by h. So this is actually part of the combinations of functions. So if I wanted to do, if I had a function where f of x is equal to x squared plus 4x plus 2, and I want to evaluate f of x plus h, right? So f of x plus h would equal to x plus h squared plus 4 times x plus h plus 2. Now remember, x plus h squared is this, right? So that's x squared plus 2 times x times h plus h squared, right? X times x is x squared. X times h is xh, and then I do h times x, and then h squared, right? So this is going to be x squared plus 2xh plus h squared, and then I go ahead and distribute this, right? Plus 4x plus 4h plus 2. And then I'm going to subtract f of x. So I'm subtracting x squared plus 4x plus 2, and then I divide it all by h. So let's go ahead and make this a little bit prettier, guys. So I've got x squared plus 2xh plus h squared plus 4x plus 4h plus 2 minus x squared minus 4x minus 2 all divided by h. Okay, Well, if you look right here, negative x squared and positive x squared cancel each other out. Negative 4x and positive 4x, again, cancel each other out. 2 and negative 2 manage to get rid of each other. So now I have 2 times x times h plus h squared plus 4h divided by h. So I'm going to go ahead and now just divide each one of these terms by h, and I get 2x plus h plus 4. Okay? Hold on. Okay. All right. So that is using the difference quotient. So I wanted to give you a couple more combinations of functions and operations on functions. I talked to you guys, and then I'll do one more equation of lines. So this is a long video, and I do apologize, but I just want to make sure you guys are ready for this test, and hopefully this will help you significantly. Okay, so if I have f of x is equal to 2x to the third, and g of x equals x squared minus 4x, define g plus f of x, and then also do f minus g of x. So g plus f of x would just be x squared minus 4x plus 2x to the third. And then the proper way to say that, or to write that, would be to be in standard form, which is 2x to the third plus x squared minus 4x. Now when you subtract, be careful. Okay, so here I have 2x cubed, and I'm subtracting x squared minus 4x, which just means that I am just changing the sign of everything, right, that's in here. So I have 2x cubed minus x squared plus 4x. Okay? And that's the combination. The other one I wanted to show you is if I have a function of, let's do f of x is equal to x squared plus 2 times x, and then g of x is equal to 3x minus 1. All right, and they're going to say, what is f of g of x, right? So what that means is I write out f of x, and I just leave blanks what's in there, right? So plus 2 times whatever f of x is, right? X is. Now, in the place of x, I'm going to put 3x minus 1, and then I simplify, okay? So 3x minus 1 squared. Remember, please be careful with that. That's 9x squared minus 6x plus 1, right? And then this is 2 times 3x minus 1 is 6x minus 2. So I'm going to, so I add 6x, and then I subtract 2. Make sure you're combining your like terms. So I get 9x squared minus 1, and that's f of g of x. Okay, finally, I want to talk about one last one where we're writing the equation of the line perpendicular to another line. So let's say I'm given an equation of a line that's 5x plus 3y equals -4. All right, write the equation of a line that's perpendicular and passes through the point 1, 4. Okay, so the first thing you need to do is determine your slope of the first line. Determine the slope of the first line. Okay, so that's going to be 5x plus, and in order to do that, I need to get this in slope-intercept form, right? Which is y equals mx plus b. All right, so I'm going to go ahead and subtract 5x from each side, and I get 3y is equal to -5x minus 4, and then I divide by 3. So y is equal to -5/3 x minus 4/3. Now your slope is right here, right? It's the number next to x. So if my slope of this line is -5/3, remember perpendicular slopes are opposite reciprocals. So opposite just means I'm changing the sign. So this is going to be, so my perpendicular slope is going to be positive, and then the reciprocal is I flip the fraction. So there's my new slope. And then I'm going to plug it in. Into point slope, which is y minus y1 equals m times x minus x1, right? And we just do our substituting like we did, right? So I'm going to do y minus 4 is equal to my slope, which is positive 3/5 times x minus 1. All right, now this is not pretty. And I think they wanted it in, right, in standard form. Okay, so we need it with no fractional coefficients. So let's put it in standard form. Remember that standard form is ax plus by equals c. All right, so first thing I need to do is I'm going to go ahead and distribute this, right? So I have y minus 4 is equal to 3/5 x minus 3/5. Okay, so the next thing I'm going to do is bring the x over to the left side of the equation. Okay, and I'm going to kind of extend this a little bit, sorry. So I have -3/5 x plus y minus 4 equals -3/5. Now, let's make life easy on ourselves and just get rid of the fraction. Now, the way to do that, I'm going to do two things. I'm going to get rid of the fraction and the negative at the beginning. Now, some people are okay with a negative at the beginning of a standard form. I will accept it both ways if I'm just grading it, but if it's on the test and you need to put it in standard form, most likely they're going to make you have the leading coefficient be positive. So in order to do that, I'm going to multiply this by -5, the whole thing. So -3/5 times 5 is just, -5, I'm sorry, is just 3x. And then that's minus 5y. That's plus 20 equals 3. Okay, so then I'm going to go ahead and subtract 20 and I get 3x minus 5y equals negative 17. Okay? So that's that in standard form. Okay? The other thing I wanted to give you, um, you'll have to do some transformation of functions. You're going to be given something with a radical and a rational function. Let me do one more problem, and I'm sorry about that. So if I have f of x equals 2 times the square root of x, and then I have g of x is equal to 1 over x minus 3. All right? And they said, okay, write the indicative function and write its domain in interval notation. Now, one of the things that you're going to have to do is when you do a combination of functions, your domain has to include both of these. So this guy is, so we're going to do f of x over g of x, f over g of x. So if I did f over g of x, that would give me 2 times the square root of x divided by 1 divided by x minus 3. Now, what does that mean? That means I have to flip this. So this is going to be 2 times the square root of x times x minus 3. Okay? Now, I would just kind of leave it like that, or you could write, sorry guys, oh annoying, sorry. Okay, there we go. I could do 2x times the square root of x minus 6 times the square root of x. The domain of this would just be x is greater than or equal to 0, right? So it goes from 0 to infinity, right? So that's definitely something you need to keep in mind. And again, I talked about the vertical line test and stuff like that. Please make sure that you submit any work so that I can give you partial credit if you need it. I hope this is helpful to you. Please give me some feedback on it other than it being over almost an hour long. I do apologize for that, but thanks a lot for watching.